Yes, I'm going to talk about teaching embedded Rust, and we have been doing that for the past year here at the university. I am Jonathan, and I'm actually a student here. So even though I've also been teaching here, I'm also studying embedded systems at the moment. And I've been working as a high school teacher for quite a bit last year. And I'm currently doing my thesis here in programming languages, which is not, well, I'm teaching for embedded systems and I'm following embedded systems, so it's an interesting combination. Yes, but I'm teaching here for 3 courses, and actually quite a few of the people here, I think about 20 to 25, are students who are doing the CESE program. We'll talk about that in a bit. And there are about 50 of you here who are not from the program here. So that also means that a bit of this talk will not be very new to 25 people who study here, but I'll try to make it interesting nonetheless. Yes, so this year we've been starting a new master's program. Well, actually, officially it hasn't started yet. It will start next year. So all of the students here have either chosen embedded systems or computer engineering, mostly because the government was slow with approving our program. So even though the program is officially not there yet, the curriculum for both embedded systems students and the computer engineering students are all the same. So they're all together in the same courses with the same requirements for that. But next year will officially be called Computer and Embedded Systems Engineering, where they sort of mashed embedded systems in the middle of computer engineering. And we've all been calling it KC, which in multiple ways doesn't really work for these letters, but call it that anyway for the rest of the program. So by merging these, it meant that, well, each of the 2 programs has a list of some compulsory courses, and by merging them, well, each of the 2 programs wanted their compulsory courses to stay. So that meant that we forced way more of the program to be fixed for everyone. And we are still talking about that, if that's really a good idea. We have some thoughts, some students have some thoughts about that, we as well. And they are not always the same, because students are saying, yeah, we aren't that free anymore to choose all the courses we want. Maybe also from other programs, which is possible here. But for us, it gives a lot of opportunities, actually, because we can work together with courses. We can assume that people have followed one course before the next, and we can cooperate better, which was a bit of a problem before, because most courses were just given by the one teacher, and they didn't really work with the other teachers who were giving the other courses, even though they were part of one big program. And quite often, each course you could just choose whatever program you were doing. So many of the students were not part of the same group either. So maybe we'll have to find a balance in the next couple of years how we actually want to do this. But for now, it's going. So we'll continue with it for now. But it also means we have a new curriculum for our program. Quite a lot of the curriculum used C before, and we decided to switch to Rust for that. And it's quite a big choice. And it came from someone we didn't really expect. Our head of our department? Yeah, the head of department, I'm not entirely sure what his job title is, was always the biggest C proponent. Like, he would do everything in C, and he always say, like, in C it would be like this, and it was way easier. So I would have never expected that, but he is the one who basically said we should switch to Rust instead. One big course for that is called the Embedded Systems Lab, and we teach people to fly with drones. Actually, I have one in the back. Let's see if I can. Cool. So we fly with these drones. We do that every week, or 3 times a week even, in the morning, in groups. And students learn to, keep them level, make all the control software for that. And we'll talk about it a bit more later on. And this used to happen in C, and that's the big, course we wanted to switch to Rust. And that's going on right now. So all the students here that are following the program will be doing that right now. And if you have questions about that, you can also ask them if they want to answer that. But yeah, we are switching to Rust, and what could go wrong? Well, students don't know Rust, teachers don't know Rust, and all the software is not in Rust. So actually quite a bit can go wrong. The good thing is students also don't really know C usually when they start. So it doesn't really change much, really. And that's not everyone, of course, but we did a few surveys, and we found that 50% of the students actually have written very little C. We have about 100 students this year. 8 of those are from electrical engineering, and they didn't do that much programming here necessarily. Some are come from computer science, they know some more programming, maybe also in C, depending on what tracks they did, but not necessarily. And our survey basically said that more than 80% of the EE students wrote less than 1,000 lines of C code ever, and 30% less than 100 lines. So that means actually people didn't really know that well either. And we also found that was a bit of a problem in the previous years, because during the embedded systems lab, where everyone had to write the control software for a drone, most students actually were quite struggling with that still. So, and not just because of all the control software, also because they just didn't really know the language yet. And that is something we sort of expect after a master study embedded systems, that you know how to build one. And some courses like real-time systems, which is actually quite related to the previous talk, do still use that, even now, even though we have switched. We're thinking about changing that as well, but we might do that in the coming years. We are switching. And the plan is this. Last year, we tested whether the embedded systems lab was possible in Rust, because if that's not possible, that really will stop us. And actually, I was part of the group that did that last year, together with Jonathan, who is here as well, and the rest aren't here. No, isn't here, and So together with Jonathan from the people here. Then teach students actually about Rust, because we did not have a course teaching about C at all, but we can change that now because we have a new curriculum. And that will also help them, with their master's program, but also to do these courses. And that's just a positive for the entire program. And because we teach a few courses now in the embedded systems lab and about Rust, and in the middle we have actually a third course, we can add some more cohesion to the entire program, because, the same people are teaching the same students for quite a while, which helps, with transmitting knowledge. And important of all, none of the teachers everyone can assume that they did a previous course, or at least most of the students did that, and we can assume a certain amount of knowledge in each course. And that started with a course called Software Fundamentals. And this is a course only students did who had an electrical engineering background. So all the students that had a software background didn't actually do this, or weren't allowed even to do this course. This is mostly for those people who had really never programmed much before, which is surprisingly common from electrical engineering, apparently, according to our surveys. We give them some basics in programming. We give them 8 lectures about it, or 8, I think. And we teach them also a bit about working together and using Git, for example. And after that, we give them a project, which is to build a NES emulator in Rust as a way to, learn to make something bigger in software. And they do that in groups also to learn to work together pretty much on these kinds of projects. So how did that go? Well, we have some students here. Does anyone want to give some feedback? You don't have to. Anne?
Sure.
Yes?
Should I come up?
Yes, please. You don't have to just say nice things, because I'm also going to talk about the things that didn't go as well as we wanted them.
Well, unfortunately for you, I quite liked it.
All right.
So I am someone with an electrical engineering background. I can attest that at this university, we don't get a lot of C. And as someone who also is a TA, I can tell you that at other universities, we see people come in with absolutely never programmed a single line of code before. So I think it's a really good idea to have a course that teaches you from the basics all the way up to a point where anyone who started embedded systems can say they've at least coded 1,000 lines of lines. Yeah, I thought it was a very positive experience.
All right, well, that's good to hear. Anyone want to say something they didn't like as much? It's also useful. We're doing a sort of course evaluation now in the middle of the Rust meetup. Anyone who wants to ask some of the students something about the courses? Okay. Well, and this is the big mistake in my slides. That I've noticed that I wanted to put it on the next slide. So I'm sorry about that. But I'll tell you about my thoughts. We taught students about Rust, and it went quite well, actually. The lectures went okay. They need improvement, but we can do that next year, and we will change a bit about that next year. Though some assignments we made, they do need changing, because we learned something about what people learn and what order we can ask questions. But yeah, and maybe we need to look at some things about group making, because we have heard, we've gotten some feedback about that, and we want to improve that next year. Yes. What also is important is that we need to look more into coordination, because we are now a cohesive program and we can, well, coordinate between the courses we give, but there are also other courses that all the students are following at the same time, because we do software fundamentals, but they also follow 2 other courses here. And we really need to talk to these people, because we should not give deadlines at the exact same time, and we should make sure that it all works and fits together. And that's one of the big things we hope to do next year, to make it all fit better. What we also did for this course is build a lot of infrastructure. So, and we also did that in Rust. So we have a website we made with Markdown Book, or MD Book, which is a Rust tool. We have set up automatic grading for lots of the assignments we made. We have an in-house developed tool called WebLab, and you can basically set assignments for students, and they can do them, and it will be automatically graded. And that's also part of the grades for this course. And assignment management is an interesting one, because WebLab is an environment where you can online make assignments and students can make them. But they're not necessarily checked into Git, for example, which means it's quite difficult to track your changes with this. So we built quite a big tool that takes a Rust project on your computer. We add some macros all around it. Macros are awesome, to be honest. And on your computer, it will just compile as a normal Rust program. You can even check if the reference solution will match all the tests you give for the students and with which you do grading. And then you can basically run a little program that exports everything, and then you get a zip file, you can upload it, and you get all the assignments for students. And we built this in Rust as well, because it was quite useful to do different macros, because we can just set up a project and it will, we can use it on our own computer and work with it in an IDE and things like that. So that was actually quite a good experience, and it means that it's quite easy to change assignments for next year, for example. And it's quite easy to set everything up for next year, which means we can improve a lot if we want to, and we do want to. But that's just the basics. So after this, we moved on to a course called Software Systems, because, well, Software Fundamentals just teaches about software. And that's only for the electrical engineering students, but well, we are doing embedded systems here. That's something we barely covered, actually, in Software Fundamentals, even though it's part of the embedded systems program, mostly because we need to teach people the fundamentals first. And Rust is quite a complicated language, and we need some time to get people used to that. So Software Systems is only half a course in our case. The other half is given by another teacher about also interesting topics, but didn't have much to do with that, to be honest. And we talk about concurrency. Mara will be happy about that, I think. About analyzing the performance of programs and about writing your own drivers, for example. So we teach people how to work with unsafe, to program for the drone in the end, right? That's what they need to do. Without an operating system, to learn to work with hardware abstraction layers and the back rates. And we do that inside of an emulator, which makes it a bit more forgiving to debug code on it. But the emulator emulates the exact same chip that's on our drones, meaning that most of the code and knowledge will transfer to the next course. So how did that go? Well, if someone has some feedback again, they can maybe share it, but I can also continue to my own thoughts. Yeah, you're a TA for it now, so that doesn't work as well. We can do a lot better for this course. So we did 4 weeks on this, and our assignments were a lot more involved in this case. In this case, there were not small assignments to teach about one concept in Rust. There were more like small projects of a week. And we need to be very careful to test the right things in that and not make people spend a lot of time on useless things. We want to teach them about, well, the concurrency and the unsafe code and the exact things. We also, especially for the embedded assignments, we want to make it easier to have students debug things and make it easier to inspect what's going on, because then they will learn more about it. And we need to generalize a bit more, because at this point, we basically noticed that we set the wrong goal with all of this. We're not just teaching students to be able to do this embedded systems lab, even though that was sort of what we were going for when we did this, because we mostly needed to make students ready to do this quite complicated project. But the thing is, we also need to teach people about just how embedded systems work, how maybe other languages do this. We don't need to just focus on Rust, even though we maybe all like that here. Well, that's a big lesson for us, actually, that we want to generalize a bit more. So next year, we actually want to give more instructions while having the lectures be more theoretical, making them a bit higher level, while the instructions and the assignments will be a bit closer to, well, we will still teach Rust, of course, that's the thing we will use, but it's only a tool to get to a certain solution, and we want to, well, maybe generalize a bit more about how we can find other ways to get to those solutions. And then right now we're doing the Embedded Systems Lab in the main hall of AWE, the big tower we have here, right in front of the elevators, which is interesting, but there was no other room, so that's what we had to do. Students will have to learn about control theory, about safety, because these things can spin quite fast and they're quite painful sometimes. So how to safely handle that, and also to make sure that the code is safe. Well, if something goes wrong, it will turn off automatically, and if you press all kinds of buttons, then it will just go to the ground and nothing will go wrong. Making sure that that's all safe. And an important thing, for example, is when you remove the cable, because it's not by default wireless, we don't want the thing to keep, well, running the motors, for example. And it's about communication, and one very big thing is integration. I think some students here will be able to confirm that, because it's a lot of software written by a team for quite a complicated system, and it all just needs to work together, and that's quite an important thing for this course. Let's see, can we run this video? It's quite fun maybe to see. It's nice. What happens when I press this video? Well, yes. Thank you. Can I? Oh, then it just opens a YouTube video.
Just go to the YouTube.
Yes. Can we show this?
Well, to
go to YouTube. There we go. Can we go there? For the students under us, we won't allow you to do this yet, but make this bigger. It would be nice if this just worked, right? So this is us flying the drones you have been using in the lab so far, and This is flying free. We won't allow you to do that yet. Only if we and you are quite confident about your software that it actually won't fly into the ceiling or into someone. But this is what we'll be working towards, and many of you probably will be able to do at the end of the lab. We hope, at least. So how's that going? Well, we're still doing it. So, well, we've had some bugs and it's not all been perfect, but most of the students are making progress, I think. And we don't know all of it yet because we're still doing this at the moment. But even this morning we had like 8 out of the 10 groups using their drones, flying, well, testing all the propellers, testing with the joystick if their mappings are correctly set up. And if you are already testing some control algorithms, like if you spin it, that it tries to resist and try to stabilize itself in the air. And quite a few students have already been making quite some progress towards actually implementing this. Because maybe if you don't know, these drones are quite unstable if you don't use things like PID systems and make sure that they are actively stabilized in the air, because otherwise, well, they'll just you can't do that by hand, pretty much. You need software to stabilize this. Let's see, how much do I, still, the other mouse, yes. So next year, that's where in the fourth quarter we don't have any courses, so then we'll take a bit of a break. Well, the students won't, but we as teachers will. We'll prepare for next year, so we'll apply some things we've learned over the past year. Mostly software systems will probably get a lot of improvements next year. Also based on all the feedback we got from the students, because we've been gathering lots of feedback. I'm not sure if, Gustavo, you may have been part of that for software systems. As I said, we need to improve our coordination, because that's honestly the biggest thing we've noticed, that we can work together now. We should as well. We should also do that, because otherwise the whole shift between the programs and curriculums didn't really help us, basically. And we do want it to have an effect on how we teach. That's pretty much the end. Does anyone have questions about what we do here? Yes? Come to the front? Well, you're already pretty much in the front, but it's mostly if you want to be on the camera or not for the recording.
I'll just...
Okay.
So if it wasn't software systems, like you did it this year, I won't like Rust this much. Like I really enjoyed.
You did enjoy software systems like it was this year?
Yes.
Okay.
Like, it's very good. It's well structured, at least for me.
Okay.
Like you made the homework feel like a 10 EC course homework, but just like made everything.
Okay. Well, yes.
Yeah.
But it maybe shouldn't be a 10 EC course. It's a 5 EC course.
Yeah.
So we need to make sure that it works for everyone. But yeah.
But it also feels like generalized, because you said something about not generalized. Like I don't feel it's towards embedded for this project, though I know something beforehand, but I feel like it's the best course I had.
Yeah. Well, we'll try to find a good balance between, some changes, keep some things the same, see what we can do about that.
But forming groups do need to be improved.
Yes, we'll think about that to make it better. Araf?
Yes.
Take a mic, come to the front.
So my question is about Rust itself.
Yes.
So, you switched to Rust, and that's great, right? Were there specific problems that existed in C that switching to Rust actually helped you solve? Or did you see vice versa, that there were some problems with Rust, the language, that C was not able to, that C could handle better?
Definitely.
Things like unsafe.
Yes. So one of the big things we think, and we thought about it as well, and lots of students are going for this during the embedded systems lab as well, is teaching about things like SERDI, like serialization, deserialization. It's hard to do that well in C. Most students for the embedded systems lab didn't know about it either, how to do this properly, and they just manually put some bytes, hopefully in the right endianness, over a wire, and that's just one big mess, to be honest. And I think that's a lot more structured now, which helps. Rust has really helped solve. There are more examples, but this is, I think, a good one. One issue, especially for the embedded systems lab we're having right now, well, it's a question. This might not be an issue to some people, but sometimes code panics in Rust, and that C really doesn't do that as much. And maybe maybe it's a good thing that we have that, because sometimes things just go wrong, and then you want to know about that. But it's sometimes hard to debug, especially with a tightly integrated system. With C, things just continue running. If that's a good thing or not is a good question. But especially right now, we've been having some bugs, and it means that people will have a lot of panics, which are hard to debug at the moment, and sometimes not even really their fault, because some integer overflows or underflows somewhere, and it's sometimes hard to account for that at the moment.
All right, cool. Thank you.
Gustavo? Yeah?
I was actually going also to answer a little bit your question.
Okay. Yeah, you can do that.
Because I've got quite a lot of experience in C, and I find out that even if it's much unsafer to do embedded C, like writing to registers, for example, becomes a pain in the ass in Rust, and especially when you have to learn it, like the type of syntax is quite complex, and I found that the documentation wasn't that easy to grasp or to find. So I think that passing from C to embedded C is almost straightforward. But passing from Rust to embedded Rust is more work, at least. Yeah, that's, I think, one of the main reasons, at least for me, why the first part of the course was like a 10 EC course and not a 5 EC course.
Well, it may be good to say, I think Gustavo was referring to things like the documentation for packs, for peripheral abstraction crates, which are mostly automatically generated, and you will go to the documentation of it and you won't find much. So that's sometimes a bit of an issue. And the good thing is that the interface is pretty much the same for all of the packs. You do have to learn it though, because there's not really that good of a documentation setup for that, which might be less desirable. Anyone who is not a student who has questions? See one here, one there.
Time for one more.
Oh, okay. Someone's coming there.
Hi.
Hello.
The name of the chips, so also the name of the emulator that you are using?
We are using QEMU,
Okay.
and this is an NRF chip, so a Nordic chip, just like the one Dion just talked about. It's a bit of an older one. You talked about the 52 and the 53, which run Embassy very well. This is an old one which doesn't, because we tested it actually last year. It doesn't run Embassy very well because it doesn't have the reason they state is it doesn't have things like direct memory access controllers, like DMA controllers, which are really helpful in this case, it turns out. So it's very poorly supported by Embassy, which is a bit of a shame. The reason we choose for it is deliberately because it's not a very powerful processor. And that's to give people some constraints to work around in this case, because it's a deep chain. That's maybe not what you would choose when you were actually building this. So for example, this system doesn't have a floating point unit, which means we force people to think about things like fixed point numbers and how to deal with that. And it isn't as easy to set up things like Embassy, and it forces people to think about this themselves for this project, which is deliberate, although, well, it's a trade-off, and it's with the chip we have now. We do this, and it's quite hard to switch now as well, because we have lots of drones that already use this. So maybe in 5 years we'll think about changing this.
All right, thanks. So